Hello everyone, this is Dr. Rajesh, and again I am with you with my new video lecture. And in this video lecture we will study that what is Newton's forward difference formula, and we will use that formula to solve the given numerical problems. We will also see that how to make a forward difference table out of the given data, and how we'll know that in this particular problem or in the given problem we shall be using the forward difference formula. So these are the questions that needs to be answered, and we will be answering them during the course of the today's lecture. So firstly we will see Newton's forward difference formula. Here this Newton suggests the name of the pioneer who have laid foundation for this formula, that is forward difference formula. So it was given by Newton. So this formula is this one. It's y naught plus p delta y naught. Delta y naught is first order forward difference operator. This is second order forward difference operator. P is defined as x minus x naught by h, and delta cube is third order forward difference operator. And here is p minus 1 by 2 decreasing, once again decreased, and here is 3 factorial. So you have to, if the problem is to solve the given data and interpolate the value using forward difference formula, firstly you will write the formula in the examination, where p is given by this one, where x naught is the initial value of the x in the given data, h is the step function, the difference between the consecutive arguments, and x is the value, that value at which the function is to be interpolated. So hence we can find p from here. So now we will form the Newton forward difference table. We will see how we can form the Newton forward difference table. This x is the argument, x naught, x1, x2, x3, x4. These are the arguments. These are the values of the function at x naught, x1, x2, x3, x4. These are the values. So first form the first order forward difference operator, that is delta fx. So that is our prime duty, to firstly make this table, forward difference table, and you all should understand that how to form this forward difference table, because this would be used in I think every possible question that we will be dealing with. As far as interpolation is concerned, this table is of prime importance, and you should give every bit of your attention to this particular formation of the table, because this is a very important aspect and we shouldn't ignore it. And firstly we will see how to form the first order forward difference operator column. So firstly in between this and this we will write delta y naught, which is y1 minus y naught. So here we will write in between this and this. If I say it is to be written in between them, so something like here. Okay, you have to write in between y0 and y1. So next you have to see this one. Next is delta y1, which is y2 minus y1. Okay, similarly it has to be written in between this and this. So next delta y2, it is being increasing y3 minus y2, delta y2, delta y3 y4 minus y3. So we have formed, since all the values in the second column has been utilized, so this is the first order forward difference operator table. So next we will form the second order forward difference operator table. So here you see this is delta square y0, delta square y1 and delta square y2. Delta square y0 is equal to delta y1 minus delta y0. Similarly delta square y1 is equal to delta y2 minus delta y1, and so on. Delta square y2 could also be written, which is difference of delta y3 minus delta y2. Similarly third order difference could be determined. Firstly we will write delta cube y0 delta cube y1. Delta cube y0 is delta square y1 minus delta y0. This will be delta cube y1 minus delta cube y0, that will be delta y0. So this completes the table, because now we cannot move further. Here only single quantity is present, so further this table could not be taken to the fifth order forward difference operator. So this is the situation here, and we have written the formula again. This is the formula is written again. So this is the, when we have to pick this delta y0, what quantity you will pick? You will pick this quantity and put it over here, and when you talk about this one, you will put this one, you will pick this one, put it over here, and for this one you will increase it and write p minus 1, p minus 2, p minus 3 divided by 4 factorial, and delta for y0. Sometime I speak it as del, but it is, if it is written simple triangle, it is delta. Sometime in a flow I speak it's del, it's actually delta 4. So this could be used after inducing it to further one more step. So these values are to be used, and p will be determining. Okay, so next we will be moving towards the example. Construct forward difference operator for the following data. Means at x is equal to 1, f of 1 is 1.1, f of 2 is 4.2, f of 3 is 9.3, f of 4 is 16.4. So I will form the table. This is the table: 1 2 3 4, 1 2 3 4, 1.1 1.1, 4.2 4.2 at 2, at 3 it's 9.3, and at 4 it's 16.4. Now how will you construct the table? You are going to write the values, okay, in the vertical column, values of x, values of y, you have written it, it is written in the horizontal, you have written it in the vertical. Then you will, delta y0 you know is y1 minus y0, y1 minus y0 will be equal to 3.1. Similarly delta y1, which will be y2 minus y1, y2 minus y1 is equal to 5.1. 9.3 minus 4.2 is 5.1. Next is delta y2, y3 minus y2, 16.4 minus 9.3 is nothing but 7.1. So second order means it will be 5.1 minus 3.1 is 2. 7.1 minus 5.1 is again 2. Next, third order delta cube, third order forward difference operator column, 2 minus 2 is 0. So this is the table. And the question was construct forward difference table for the following data, and we have constructed the table, and that table has come up to the third order forward difference operator. Now we are studying this. Find sine 52 degree. Okay, using the following values. This sine 45 is given this one, 50 is given by this, 55 is given, and 60 you well know is given by this one. So you have to find 52. You don't know the formula of sine, but the given for these 4 points you have to find the value of sine 52 degree. Now let me first form the table. You know this thing is given. This is written in the horizontal ones, and now I have written in the vertical ones. So here you see this difference is this one, this minus this is this one, and next is 0.8660 minus 0.8192. So this is 0.0468. 0 is also called as O in British pronunciation. So next is delta square. So this 0.0532 minus 0.589 is minus 0.57. You could also do with the help of the calculator or simple calculation. This minus this is this one. This is delta square. This is delta cube. So this is minus. When minus will be subtracted, it will become plus. So this will be minus 0.0007. So this is the table that we have formed of the given numerical problem. This problem we have formed the table. Now h, the difference between the arguments is 5. X at which the value of the function is to be determined or to be interpolated is 52 degree. Look over here. Once again I go back. At 52 it is required to be determined. And we know that P is equal to x minus x naught by h. X is 52 minus 45 is the initial value. Initial value is x naught, and h is the step. Step is here 5. So this is 5, and we will write the various values. 52 minus 45 divided by 5 is nothing but 1.4, and question is running in the degrees, so it is 1.4 degree. Now using Newton forward formula, we know that this is equal to this one, and we have to third order. You could easily write up to third order. It will be p minus 1 p minus 2 by 3 factorial, and even you have to put the values. You will use at place this one, you will use this value of second order, and the only value is this one of third order. Fine. And y naught is the first value. So these values are to be used. Okay, so you have to use these values over here. So these values are used. This one p you know, and here you put p minus 1 is 0.5. This value of delta square is used. Delta cube, this value is used. 3 factorial is 6. So when this will be calculated, this will give 0.7880. 0. So this is the required value of sine at 52 degree, and that we have interpolated with the help of the given data using the Newton forward difference formula. So that is very important. So you are asked to construct Newton forward interpolation polynomial for the following data. Use it to find the value of x. Firstly, formulate the polynomial, then put x is equal to 5 in that polynomial and find the value of the function. You know, at 4 it is 1, at 6 it is 3, at 8 it is 8, at 10 it is 16. These values are given. So here is x 4, 6, 8, 10, y 1, 3, 8, 6, 1, 3, 8, 6. This is delta. 3 minus 1 is 2, 8 minus 3 is 5, 16 minus 8 is 8. So this you will use. This 3 minus 1 is 2, 8 minus 3 is 5, 16 minus 8 is 8. Similarly, 5 minus 2 right in between. Okay, this will be 3, 3, and third order will be 0. So we have constructed the table. So this is the table, and here h is 2. You will see that here the difference is 4, 6, 8, 10. So 6 minus 4 is 2, 8 minus 6 is 2. So it is 2. Step is 2. Equally spaced interval. Initial value is 4 and x is equal to 5. Using Newton's forward interpolation formula, we know, and you know, you have to substitute the values, this value, this value, and this value. 1 plus 0.5 into 2 plus 0.5 minus 0.5 into 3. This value is used by 2, and this is 0. So this is the Newton forward interpolation formula for that particular table. We have used the values. So these values are used. You can see these are in yellow color and these values are used. So when it will be solved, it will give y of 5 as 1.625. So now question is, we have to interpolate the value through the polynomial. Firstly, we will try to form the polynomial. Instead of x is equal to 5, now we will take general x is equal to x. So p will be x minus 4 by 2 using Newton forward interpolation formula, because now we are interested in polynomial. So therefore in specific we have not taken any value of x which is and that has to be fall near the beginning of the table, because x5 was in the beginning of the table. So it has to be some value, it could be any value that is near to the table. It couldn't be at the end of the table. So in general x is taken as x and this value is near to the table. So we know by Newton forward difference interpolation formula, you know this one, and now I have substituted the values p here. This p minus 1 delta square y naught, that is put it over here, that is 3 by 2. You could see the values from here. Delta square y naught is 3. This is 3 and this is 2. So this when solved, this will multiply and take the LCM, we got the polynomial. And when you will put the value over here 5, you will see the result in the both the cases will be same. So this question is very important, because in this not only we have just interpolated the value of the function at any given point, but also we have determined the interpolating polynomial, and through which we also interpolated that particular value which was initially interpolated with the help of Newton forward interpolation formula. So that question is very important from the examination point of view, and today we have discussed Newton forward interpolation formula, what are the circumstances under which we have to apply the Newton forward interpolation formula, and what are the conditions under which this formula could be applied. And then we have studied the technique that how we could use this interpolation formula to interpolate the value of the function at given point from the given table. So here we also studied to approximate or to find the interpolating polynomial by taking x as general x. So the polynomial thus obtained when replaced with the value which is required to be found will give the value of the function at that particular point. So this Newton forward difference interpolation formula is very important from examination point of view, and I hope that you all will prepare this very sincerely. And that is all I have from this lecture. In the next lecture we will be dealing with Newton's backward interpolation formula. Till then, you keep studying. Take care. Bye bye. Stay healthy. Stay safe. This is Dr. Rajesh saying you goodbye. Take care. Bye bye. See you